This will be the first in a series of videos on the Rife system, and we'll deal with the tools you'll need and the parts you'll use to make a Rife wire adapter kit. I start with a piece of shim stock I got from the manufacturer. This piece is 12 inches long and 2 inches wide. I use a metal blade on a chop saw to cut squares of 2 inches. Then I work these to round the corners, smooth the edges, and I have a small drill press to drill a 1/8 inch hole for connection. The connectors you use, what I like is this one. It's designed for a number 4 to number 6 post, which means it has about a 1/8 inch opening. The part where the wire goes in this case, is a 14 to 16 AWG opening. The wire I use is 22 gauge speaker wire, just 2 conductors, and it comes on various size spools. The ones I like are 100 feet, so I can get 10 units out of a single spool. Now the reason I use 14 to 16 gauge openings in these is because if I was to use 22 gauge openings on a 22 gauge wire, that would mean you would strip the wire and stick the copper in the connection and then crimp it. And this makes a very weak connection, and it's almost bound to break very quickly as it bends, and the copper will break. By using the larger one, 14 to 16, I can strip the wire, fold it over the insulation, and stick the insulation and the wire into the connection and crimp that, and it makes a very strong connection that you would really have to work to break, because you're dealing with the strength of the wire plus the strength of the insulation. This is the package that these things come in, but they come in various amounts and packages. I don't know if you'll be able to read it, but it's a number 4 to 6 post and 14 to 16 American wire gauge. The way you attach this after it's on the wire to the plate through the 1/8 inch hole is using this, which is a pop rivet. The pop rivet is used with a special tool, which is this pop riveting tool. Now I've stuck it into the boss here, and then I spread the handles, and there are grabs inside there, and you can see that the rivet has seated onto the boss. Now you have a shoulder and this ball, and when I squeeze the handles, the ball goes into this hollow sleeve and expands so that you get a joint between the shoulder of the rivet and the expanded center, the body of the rivet. And when you get enough tension on it, this ball will pop right off the end. It'll break the stud. I've dropped it out now by spreading the handles the other way. This is the jack I mostly use. It's a 1/4 inch stereo jack. This is the tip, this is the ring, and this is the post, which you consider to be ground. You can see the black rings of insulation in between. And in a stereo application, this would be right, this would be left probably, and this would be ground. The extension here is to ground. Then right up here by the white are 2 very small connections to the tip and the ring. And what I do is I run the wire through the holes after I tin it. I put solder on it to make the tip and the ring common, because you're using only two conductors. So you'll have one side will be the tip and the ring common, and the other side will be the post. And I solder onto all that. I use about a 1/8 inch diameter solder, standard rosin core solder. These are the helping hands. They're a couple of alligator clips, and everything on this is adjustable, so you can hold the jacks or the wires while you tin it or while you're making your solder connections. Here's the soldering station. It's a Weller. Now, this is a completed kit that I use myself. I built this probably in the year 2000 and still use it. I've covered the plates with cloth because I permeate that with salt water, just table salt mixed with water, so that I spread the electrical signal. You want it spread as wide as you can when it's on your body. The tools used, other tools, needle nose pliers. That's used to crush this part of the jack so it grabs the wire and makes a strong join. Wire cutters to cut your 22 gauge wire. The crimping tool that you use to crimp the connections, which they go right in here where my finger is, and then they get crushed flat. This tool also has wire stripper for the 22 gauge wire. This is a standard volt ohm meter, costs about $22. And I use this to check every connection I make, to make sure I've got good continuity. So I switch it to a resistance setting, touch the probes, and you can see the needle go all the way to the right, which is what you want. That means you've got a full connection. So that's it. Thank you for watching and listening.